In this video, we're going to start discussing some of the basic functions that we're going to be utilizing in this chapter. And so we're just going to start getting familiar with what the graphs of these functions look like before we start graphing transformations of these functions. So these are the functions we're going to be looking at in this section. We have x squared, x cubed, square root of x, cube root of x, and the absolute value of x. So let's just start by getting an idea of what each of these functions' graph is going to look like. And so one way we can do that is to just start plotting some points. Although before we do that, it might be helpful to think about what x values we are able to even substitute into the function. So in other words, what is the domain? So here, we can substitute any real number for x. If you take any real number and square it, you get another real number. So the domain here is all reals. So to get an idea of what this graph looks like, we probably just want to choose a variety, maybe a couple negative values, 0, and a couple positive values. And we're just going to substitute each x value into the function and then see what the corresponding y value is. And so once we do that, then we have some points that we can plot. And so by plotting these points, we kind of get a sense of what the graph is going to look like. We're never going to square a real number and get something negative. So that point 0, 0 is the lowest one on the graph. And you probably knew from a previous algebra course anyway that this is going to be a parabola. So it's a parabola with the vertex at the origin and it opens up. And so the range then, since the lowest y value is 0, and then every other y value shows up somewhere on this graph, then the range is all numbers greater than or equal to 0. All right, let's look at the function y equals x cubed. So again, we want to think about what values could we substitute for x. And here again, we can substitute any real number for x and the output will be a real number. So the domain is all reals. So let's just choose a variety. I'm just going to use the same ones we did for the previous function. And so we'll just substitute those into the function and see what the y values are. So negative 2 cubed is negative 8. Negative 1 cubed is negative 1. And so on. Okay, so I've plotted my points, and you can imagine that as we take larger and larger values of x, like 3, 4, 5, the y values are going to get really big, and similarly if we take more negative x values, the y values will continue to get more negative as well. So we have this shape that kind of goes down. It does not go straight up and down despite how I'm drawing it on here. It's a little tricky drawing on the iPad, but this is going to be a very steep curve, but it's not going to become vertical like it looks in my drawing. So that's the general shape, and then the range then, we can see if we follow the graph far enough in one direction or the other, we could eventually reach any y value that we had in mind. So the range is going to be all real numbers. Okay, here we're going to look at y equals square root of x. So if we think about the domain here, the only number that you can't take the square root of and get a real number output is negative numbers. Right? We can take the square root of anything positive. We can take the square root of 0. Just the square root of a negative number will not be real. And we only graph real numbers this semester. So the domain then is all numbers greater than or equal to 0. So when we're plotting points, we're not going to choose any negative x's. So we'll want to choose 0 for sure, and then some positive ones. I'm just going to choose some that will work out nicely when we go to take the square root of them. So square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. And if you continue increasing the x values, the y values will continue to increase. For example, if x is 9, y is 3. If x is 16, y is 4. So this is going to go up. It is going to increase as we go to the right. Now the range is not going to be all reals this time. For example, we don't see any negative y values on this graph because it's starting at the origin and going up. So we don't have any negative y values, but 0 appears on the graph at that first point that we plotted. And if you pick any positive y value, you can find a point on this graph with that y value. So the range is all numbers that are greater than or equal to 0. Okay, let's look at the cube root of x. Now you can actually take the cube root of any real number because it's an odd index root. If you take the cube root of any real number, you will get a real number output. So the domain is all reals here. So we can substitute anything we want for x. I am going to choose numbers that have a nice cube root that will give us a nice easy point to plot. So for example, the cube root of negative 8 is negative 2. So I'm going to use that point. Cube root of negative 1 is negative 1. 0, 0, 1, 1, and then the cube root of 8 is 2. I'm doing the best I can graphing these on the iPad, so pardon my bad drawings. But what we're seeing here is as we take larger x's, we do get larger y's, and smaller x's are going to result in smaller y values. So this graph's going to increase the whole time here. And it's just going to keep going forever in each direction since we can choose any x value that we want. So it looks similar to what we had for x cubed, except that x cubed increases really rapidly. Right? We go from the 0.11 to the 0.28, increasing really rapidly. Here we go from the 0.11 to the 0.82, so not a very fast increase there. And the range is all reals. The graph goes forever up and down, so any y value we could ever think of shows up somewhere on this graph. Alright, here's our last one, absolute value of x. You can take the absolute value of any real number and you will get a real number output. So the domain is all reals. So we're just going to choose a variety of x values and substitute them into the function. So we get a symmetric graph. It's symmetric about the y-axis, just like our parabola was. But this one's not a parabola because the slope between each pair of points is the same. So these points on the right half are all falling on the same straight line. And then these points on the left half are all falling on the same straight line. So we get this V shape here for our absolute value graph. And we don't have any negative y values because you can't take the absolute value of a real number and get a negative result. But we do see 0 on the graph, and then any positive y value you could think of would show up at some point. So all numbers greater than or equal to 0 is the range. So we're going to be working in future videos with these functions, and we're going to be graphing transformations. So these 5 basic functions that we looked at here are kind of going to be what we start with, and then we're going to manipulate the graphs. So it's helpful to know what the general shape looks like. For example, it's helpful maybe to know that the absolute value of x is a v-shaped graph. But please do not think that you need to memorize like this table, for example. Don't memorize it. How did we get that? Well, we picked some x values, plugged them in, and saw what the y value was. So you don't need to memorize that. You really don't even need to memorize the domain and range for each of these. If you can sketch a graph by plotting points, you can figure out what those are. So I think it is helpful to have in the back of your mind what the shape of each of these 5 graphs looks like. But even if you have a mental block and forget, you could always plot some points and figure out what it looks like.